Hello everyone and welcome to Prof Talks. Today we'll have a look at the 483 observations issued for Biocon Biologics Bangalore for the USFDA inspection conducted in July 2024. This is a sterile formulation facility and 10 483 observations have been issued. Kindly note that this presentation is solely for the purpose of learning through these 483 observations. The inspection was conducted for 10 working days from 15th July 24 to 26th July 24. There were 4 inspectors, Justion, Teresa Neves, Richard Ledwick, who is a biological expert, and Xiaoxi Wang, who is mentioned as the staff. So this is a 14-page report and which includes 10 483 observations.
Before moving ahead, please ensure that you have subscribed to the channel Prof Talks and have pressed the bell icon so that you can receive the notification of the upcoming presentations.
Designed to prevent microbiological contamination of the product do not include adequate validation of the aseptic process. So there are 5 sub-observations under this first 483. First sub-observation is related to airflow visualization studies for the aseptic line for the US market did not meet the acceptance criteria of airflow that must be unidirectional and free from turbulence. So under this first subpoint, there are 5 different examples given. The first example is in the area where maybe it is a redacted thing, we can read it as vials. So where empty vials are opened and exposed to the environment, there's a gap between the overhead HEPA filters of some approximately distance. So the raw video footage of the smoke studies show air turbulence and upward flowing air in this particular area. So this was deficient and this deficient airflow was not included into the final edited version of the videos in the validation report. The second subpoint states that video shows upward flowing smoke along the RABS barrier inside the filling and the stoppering RABS. So this area is below an approximate gap between the edge of HEPA filter and the RABS barrier. The validation report did not identify any deficiencies in the area. A similar gap between the RABS was existent all sides of the RABS filling barrier. The airflow visualization studies have not thoroughly evaluated this gap. The third point is the video shows upward flowing and turbulent airflow near the gap between the HEPA filter edge and the barrier outside the filling barrier. So that there is an approximate gap between the edge of the HEPA filter and the RABS barrier. This grade A classified area is used during the assembling of the machine and interventions. The raw video footage showing this deficient airflow pattern was not included in the final version. The fourth point is the barrier used to open and load maybe empty vials has a support positioned below the HEPA filter. The smoke study did not thoroughly evaluate the impact of this particular support on the airflow. And the last subpoint, the protocol for the smoke studies state that smoke need to be introduced by placing the nozzle with the smoke upwards and the nozzle should be moved to cover the entire area of the filter. Raw video files show that smoke nozzle was indeed pointed in the downward direction and it was not moving, it was fixed location. The final edited videos did not show the smoke from where it was introduced near the filter to the working location. The second subpoint under the first 483 is again related to the airflow visualizations of the vial filling aseptic line. So the first example, it states in the grade A areas there are gaps between adjacent HEPA filters and between the barriers and the edge of the HEPA filters. These areas have not been thoroughly assessed during airflow studies. So it gives 2 examples where there's a gap between LF 14 and 15 and LF 16 and 17. So these areas have not been properly evaluated. The second point, smoke studies to support interventions for vial removal and stopper removal from stopper track. So do not demonstrate the good aseptic processing practices. So during the smoke studies to remove vials or stoppers from the stoppers track appear to violate the first air principle on the remaining containers and stoppers. The smoke study to demonstrate that the firm can replace them during production appears to show that the glove covering or touching the tubing, which is the part of the aseptic process. The third point, smoke studies to demonstrate that personnel carts and equipment crossing the grade A conveyor area to demonstrate unidirectional airflow at critical locations within the filling line or during interventions in the vial filling line are not provided. The third subpoint under the first 483, For the vial filling lines, aseptic filling line of the airflow visualization study do not demonstrate airflow appropriately from filling room into the grade B corridor and from B corridor into the entrance and exit change room. So they do not provide visualization of the airflow pattern during the operational conditions. Also, air visualization for the laminar airflow inside the wrap does not show enough details or angles to verify the laminar airflow in the grade A areas. The fourth point, during smoke studies for the US market aseptic filling lines, the smoke generated in the grade B areas and held over the individuals performing interventions into the grade A used some specific smoke generator. So there has been no demonstration to show that these particles would demonstrate a neutral buoyancy during airflow pattern evaluations. The fifth point and the last point in the first 483 is the categorization of the defects that have a potential of risk contamination are not adequate. So there was a media fill failure and it was attributed to both the position and the liquid found in the stopper. Neither of these defects is considered as a critical defect even though the firm's media fill failure investigation has attributed it as a risk to the sterility assurance. The position in the stopper is categorized as a minor defect and the liquid on the stopper is categorized as a major defect during the visual inspection. The second 483 observation is related to procedures designed to prevent microbiological contamination of the products are not followed. Again, there are 5 sub-observations. So the first one is on the aseptic filling line during aseptic filling batches for the US market, the operators were observed to extend the gloves over the sterile stopper bowl and sterile stoppers during interventions to add the stoppers. Second observation, there were multiple examples that the aseptic processing areas and periodic review of aseptic behavior SOP was not followed. So it includes that operator opened the wrapping of the sterile glove outside the wraps barrier. Employees did not sanitize their hands prior to interventions performed near the vial feed area after touching the HMI panel. Employees did not stop the vial feeding during clearance of fallen vials interventions performed near the vial feed area. Employee crossed the grade A conveyor belt area located without sanitizing the ramps. Employees opened the filling areas using their hands and not the elbows. Employees did not move slow and deliberate. Employees appeared to rest against the filling room walls. The third observation under the second 483, the vial filling line is not designed to minimize the crossing the grade A laminar airflow through conveyor as personnel can only enter the rear side of the filling line and must cross the grade A laminar flow conveyor to exit the front side of the fill line. Equipment needed on the rear side of the fill line operations must enter the front side of the fill line and brought across the grade A laminar airflow area to the rear side. So there were around 4 observations made for this. The first of which is there is no limit to the number of personnel or cart or equipment that can traverse the grade A conveyor that is located between the stoppering stations and the loading stations, both during the setup and the operation. Crossing the laminar requires manual disassembling and reassembling using gloves. So it was observed that greater than 30 crossings of grade A laminar airflow by personnel alone or with a cart during the setup of the filling operations. So this line was used for filling of the US market batches. Personnel crossing of the grade A conveyor are not considered as an intervention and not appropriately documented. The number of persons and cart crossing the grade A conveyor are not purposefully challenged in the aseptic process simulations. The next point is, during filling, manufacturing operations began immediately after cleaning was completed for the grade A area. However, as per the SOP, there is a certain waiting period before the production can resume, which was not followed. During filling, the personnel were crossing back and forth through the grade A conveyor area during an intervention in the fill line where stoppers are being loaded into the stopper machine. The stopper is located adjacent to the grade A area. The fourth observation under the second 483 is during filling of the batch, there was an intervention where vials were removed from the line while reaching over the remaining open container closures that were used in the subsequent manufacturing. Again, there are certain 2 examples given under the 5th subpoint. During aseptic filling, an operator performed an intervention to add stoppers. However, the operator was observed to use their hands and arm over the sterile stoppers and stopper bowl during addition of the stoppers. Operator then held their hand over the stopper bowl between addition of the stopper bags. Next point is, after the personal monitoring of hands and forearms conducted at the end of the intervention, an operator did not immediately change their gloves and subsequently touched the filling machine HMI screen. The third 483 observation is related to laboratory test procedures and controls are not established and followed. So there are 4 observations. The first one of it states that test procedures are not followed for integration of the chromatograms. So there was one testing where analyst initially applied the standard processing method, which was in line with the standard test procedure, analytical method validation, and approved integration for the stability time points. This resulted into an OS. However, without adequate justification, the analysts were permitted to reprocess this chromatogram, which reduced the area integrated and thus changed these results from OS to within specification. So there's an example given for the initial reprocessed chromatogram. The stability examples are given for 36-month and 48-month, which were OS, and after reprocessing, it was within the specification. So it states that permission assigned to the analyst in the Empower chromatography software include the ability to view quantitation peak fields in review. This allows the analyst to see the area count and results before deciding whether to save the reprocessed chromatogram or enter additional integration parameters. SOP requires any change to the process to be done by changing one parameter at a time. However, the analysts do not save the results after each parameter is changed. Only the final chromatogram is saved. The second point under the third 483, so the return procedures are inadequate to ensure appropriate quality control for the determination of HPLC. Specifically, one of the system suitability criteria for the analytical method is post peak to the main peak at a relative retention time. Some specific retention time is given, should be observed. So according to the method validation result, the first peak post to the main peak was selected for the system suitability evaluation. However, after reviewing of the historical data, the inspectors noted that system suitability for the past 2 years, it was observed that different post peaks were eluded within the RRT range that was different, and thus the analyst inconsistently selected a peak for the system suitability evaluation other than specified. So the retrospective evaluation over the past 2 years showed a different RRT range. It was uniformly selected for system suitability evaluation. About 35% of the reported assay which passed the system suitability criteria would have been invalid. The RRT peak is critical because RRT is taken into consideration into the integration procedure. The next point, it states that a standard operating procedure for the electropherograms required during the NRCE-SDS be integrated first using a standard processing method. If that does not provide adequate integration, procedure allows modification to optimize the process methods by making changes one at a time. Only after that, a manual methods and manual integration can be done. However, on review, it was found that no attempt was made to optimize the processing method before using manual integration. The fourth point specifically is related to the establishment of OOT investigation process. So it states that there is no procedure established to identify and investigate the OOT, and 2 examples are given. A percentage basis variance has a specification during the bulk stability testing and it is expected to increase during the shelf life. So results at 36-month time point were evaluated. So they were much close to the limit, but there was no investigation process in place until an OS is observed. Second point, it states that unexpected results are not investigated. For example, for CESDS, non-reducing has a percentage limit and is expected to increase over the time. So it gives an example of 12-month time point and a 3-month time point, which were almost an OOT, but they were not evaluated or investigated. The fourth 483 observation is computerized system lack control and review of electronic data to prevent omission of data. So there are 6 subpoints under this. First of which states the electronic data for the NVPC showed results that failed to meet the acceptance criteria, which had not been reported in the paper records. Operators are supposed to transcribe the result into a paper logbook and attach the printouts, which are reviewed. There is no review of the source electronic data to ensure all data is reported. There are examples given where first example is like at certain point on July 4, 2024, the micron particle limit of not more than some specific point has already exceeded with a result of 57 when the test was stopped. And there are further few example givens. Review of the older data than April 24 was not possible because data is not being backed up and have been overwritten. A risk assessment on June 28, 2024 was performed by the data governance group and identified the potential for not reporting the data in these systems. However, the assessment resulted into no action to review the source electronic data. Rather, it allowed the reliance on the printout. The assessment did not evaluate the need to backup of the electronic data. The second observation under the fourth 483 states that CESDS testing is performed for the release testing and stability testing on two specific instruments that use some 32-carat software. Neither of these instruments has been configured to save the electro for results. Only the final results is saved as the analyst changes the processing method and uses the manual integration. Earlier in 2021, there was a deviation when the electronic data did not match to the CESDS analysis on some different instruments than the above two, which uses the same software. The investigation found that system has not been configured to save all results and updated with this configuration. The investigation was not extended to evaluate all instruments and ensure that they have been configured. A gap assessment by the data governance team was carried out in Feb 2024 for this CARAT software. The failure to save all data was not identified during the gap assessment. The third point states that production supervisors have been given access to delete results in some particular integrity testing equipment. The gap assessment of February 2024, which was performed by the data governance team, did not address the delete privilege granted to these production supervisors. The next observation under the 483, audit trail review procedures for production software are general and do not contain instructions specific to the different softwares to ensure a thorough review of the data. Audit trail reviews for the software are done on the printout copies and do not evaluate the source data. The fifth observation, investigation into a loss of data point of the software notes that this was only occurrence for the loss of data. However, review of the work orders show the incident has occurred for the last 8 times prior to opening of this investigation. So during this deviation investigation, there was no evaluation of the work orders to consider whether this event was recurring. The corrective action for the loss of data was to open a change control for upgrade of the software, but the change control does not contain information associated with the mitigation strategy till the new software has been obtained. Last point on the 4483 is raw data video files of the smoke studies conducted to qualify the filling line located in the building were not available. The fifth 483 observation is investigations of unexplained discrepancies was not extended to other batches. So there are 8 sub-observations under this fifth 483. First one is investigation was not thorough and expanded to assess the full scope of investigation. So there was an investigation where it was found that persons have inappropriately changed the set points to underestimate the alarms for differential pressure, temperature and relative humidity in the building for the aseptic manufacturing facility. The investigation found that these inappropriate changes were a quick fix instead of addressing the frequent alarms. The investigation found out that calibration records generated by the third-party vendor did not detect these discrepancies and did not report the accurate data. So the investigation did not include attempts to interview the third-party calibration that generated these calibration records. It did not identify the full scope of work performed by the third-party calibration vendor at this site and any other potential impact. The investigation identified a lack of oversight of the third-party calibration work by on-site engineering person, and it did not expand to evaluate work performed by other third parties performing calibration and qualification activities. This investigation also identified that IT personnel has an inadequate GMP understanding and provided administrator access to the persons who did not have been approved by quality. There was no assessment of the work request made to IT from all departments to determine if these requests have been granted by IT personnel to provide administrative access. The second investigation states that an environmental monitoring trending program does not include evaluation of route of ingress into the aseptic grades A and B for recovered fungi, mold, and gram-negative organisms. Prior to February 24, the site would not conduct investigation for the trends if they revealed recovery rate or action limit excursions. The third observation, there were 3 deviations related to drug product spilling into the fill line through an air vent filter. The investigation did not thoroughly assess the risk of microbial ingress due to wetting of the vent filter when deciding to release the batches. The fourth observation under the fifth sub 483 is there were multiple deviations around 3 initiated since Jan to May 2024 that describes the forceps used in the vial filling line released discolored particles into the solution upon swabbing the forceps to assess microbial growth during post-batch environmental monitoring in grade A fill line. The identity of these particles have not been analytically identified. When a wipe was used to clean the forceps, noticeable stains was left onto the wipe. Forceps are used throughout the filling operations. The fifth point is there are more than 10 deviations regarding exceeding of hold times in the product manufacturing. So in 3 of the deviations, the quality unit released the product based on limited data that covered the excursion, typically a single batch. So the quality unit has not implemented appropriate preventive controls to prevent recurrence or conducted studies to justify extending hold times. The sixth point is there is no process to routinely identify visible particle rejects during visual inspection in order to identify and minimize particulate sources in the filling aseptic areas. Seventh point is NVPC data associated with the batch showed error in numerous instances where continuous monitoring probes did not provide a result. The personnel that had reviewed the approved the data did not know what these errors meant or what was the impact. The record was approved by QA without comment or actions to investigate the cause or the impact of these repeated errors. The eighth observation under the fifth 483, there has been no investigation for the repeated measurements at multiple drug substance steps where the measurements were outside the defined range of the BMR. There is no assurance that the results obtained from measurement are consistent for use in the subsequent steps. Specifically, during the process, the BMR describes that in case a solution measured is not in the BMR range, the result is allowed to be verified using the other instrument on sample collected from the dash or some XYZ system. However, when one of the solution measurement are within the BMR ranges, verification is not performed. So there are 4 examples given where it was measured and the results was accepted. The sixth 483 observation is related to the equipment used in manufacturing are not maintained in a manner to prevent malfunction that would alter drug product quality. So there are 6 observations noted under this 483. The first one, during review of the BMS data from 22 to 24, numerous excursions was observed in the temperature as well as the differential pressure. So the firm do not evaluate the numerical raw data reports for the noted parameters. Instead, only review the 10 graph. Although excursions of high differential pressure have caused a reverse airflow from a specific area, no upper limit value has been defined for alert or the action limits. In July 2024, the differential pressure in the women's entry change room in grade C corridor was below the limit and the door would not close. Also during the walkthrough, the differential pressure was below for some specified instruments. During review of the equipment, there were at least 40 work orders opened for the aseptic equipment repairs which were extended beyond 100 days. The fourth point, equipment work orders also revealed recurring issues such as leak test failures, leakages into the area or the data loss. So this caused the process time extension which caused the site returned the bulk drug to the freezing condition to be thawed on a different day. The batch was ultimately rejected after filling. Equipment log also showed that the leak test for batch was repeated 3 times in 2023 and for the next batch it was repeated 2 times in 2024. Again, during the time of inspection in July 2024, there was a leakage in the technical area near the building. It was first observed at around 120. Upon return, approximately after some time, the leak was still occurring withstanding. Although there was an employee working in this area, no notification has been made to the maintenance personnel to address the issue. Sixth point is preventive maintenance record for instruments like LAF located in the filling area do not identify the instruments used for verifying the laminar airflow and pressures. Thus, they cannot be traced to ensure that they have been calibrated and are suitable. The seventh observation is aseptic processing areas are deficient regarding the system of control of monitoring the environmental controls. So there is no NVPC monitoring at the maybe RABS barrier where the vials are opened and loaded into the filling line. This area has frequent operator intervention and open interventions are present in this area, or open vials are present in this area. The NVPC data associated is taken outside the barrier used to perform the aseptic connection on the filling line. The eighth observation is aseptic processing areas are deficient regarding the system for disinfecting the equipment to produce aseptic condition. So review of the disinfection of the aseptic filling lines was carried out and it was noted in the filling room. For example, the RABS barrier used for or maybe mobile LAFs for opening the empty vials were moved out of the grade B area of the room. So there are some ancillary equipments, maybe we can consider it as mobile LAFs or something. So move outside into the grade B area of the room during floor mopping and during disinfection. So when they are returned to grade A, they are not disinfected in grade A before beginning of the aseptic operations. Second point is during disinfection of the maybe RABS barrier onto the aseptic filling line, an operator was observed to use the same wipe on the outer surface, that is grade B side, and then again the same wipe on the grade A side. This cleaning procedure does not specify any order of the disinfection of the surfaces. Moving between grade B and grade A areas with the same wiping tool was observed during the disinfection of the vial filling line. The ninth observation, there was no return procedure for production and process control designed to assure that the drug products have quality and purity they purport to possess. So the firm qualifies the employee who perform 100% manual visual inspection of the sterile products using separate kits of particles of known sizes and other defects. The kits used to evaluate the employee's ability to detect different particles of known sizes are not representative of the visual inspection process that would be performed during the batch evaluation, as they do not challenge the ability of the employees to identify particles among other defects. 10th and the final observation is the labeling of GMP material is inadequate. So during the time of inspection in July 24, frozen sampling bags were observed in the QC freezer in the QC lab. The samples were bulk harvest reserved for advantageous agents and mycoplasma testing. The prints on these labels were illegible due to the low temperature storage.
With this, we come to the end of this presentation. Hope you have liked this presentation. Kindly subscribe to the channel Prof Talks to get more information onto the pharmaceutical quality system. Thank you.